Welcome back to my YouTube channel. So today is the part 2 of simplest road to crack GPAT series, and today we will be covering pharmaceutical chemistry, which is further divided into organic chemistry, inorganic chemistry and medicinal chemistry. So the number one thing that you have to do, you cannot leave, is the SAR. I know it is difficult in medchem to go through each and every SAR, but there are certain categories like fluoroquinolones, like parasympathomimetic, like acetylcholine. You need to know that adding which group or removing which group will affect the activity. So you can just remember which groups are responsible for increasing the activity. So automatically, if you see any other group, it will diminish the activity. So you just need to remember one part of that SAR, either those groups that will increase or those groups that will alleviate the activity. Next up is the chemical classification. So speaking about the antihistaminics, so you have chemical classification like amino alkyl ethers, you have diphenhydramine, doxylamine, dimenhydrinate, you have piperazine containing. So there are different chemical classification that you need to see for the chemistry point of view. The combinatorial chemistry, sometimes question would be asked upon solid phase synthesis, solution phase synthesis. So you need to know that cleavage, deprotection, cyclization, what are these concepts. Next up we have is radioactivity. So radioactivity basically has alpha, beta and gamma particles. So you need to know the difference between them. What is the change in the atomic number, atomic mass number, how much is the ionization power, how much is the penetration power, and like certain radioactive isotopes like iodine 131. It is used in the treatment of cancer. Tellurium 99. It is also used in many disorders. So like this, there are certain radioisotopes that are responsible for therapeutic activity. Step isomerism. Isomerism is of two types: stereoisomers and substitutional isomers. Stereoisomer is further of two types: configurational and conformational. Again, you have subtypes like enantiomers, geometric isomers, optical isomers, various configurations like R, S, E, Z, SANTI, staggered eclipse, chair boat. So you need to know the stability order. You need to know the energy order. So stability order is chair form is more stable than twist boat, is more stable than boat, and is more stable than half chair. And energy will be totally opposite. Half chair has more energy, followed by boat, followed by twist boat, and then chair. So you need to know the isomerism, the examples. You need to know the concept that if are these chain isomers, are these functional isomers, are these tautomers, are these metamers. Next up, we have name reactions. We have around 62 name reactions, and you need to know the reaction condition, acidic or basic. Like Wolff-Kishner, it is in basic condition, hydrazine. But if you speak about Clemenson, it is zinc amalgam, HCl. It is an acidic condition. So you need to know the reactant and product. Suppose if it's amide to amine, suppose if it's alcohol to ketone, suppose if it's ketoxime to amide. So you must immediately know that it is Beckmann's rearrangement. It is Baeyer-Willigel oxidation if it's ketone to ester. So name reaction ka reactant, product and the conditions, or if there's any special catalyst. Like in Oppenauer and Mervyn Pond of Worley, there is one specific catalyst that is known as aluminium isopropoxide. So that catalyst is quite specific for the oxidation and reduction. So that is why you need to know these other major parts that you need to know for the name reactions. Next up we have is qualitative tests. So there are various qualitative tests like Victor-Meyer test, Lucas test for alcohols. We have ferric chloride test, bromine water test, ester test, Benedict Tollens like for aldehydes, ketones, distinguishing them, Schiff's reagent. So you need to know the reagent, the color change, and what group is it detecting. Next up is difference between SN1, SN2, E1, E2, and the rules associated like Markovnikov, anti-Markovnikov, Setzeff rule, Hoffman's rule. So these rules you must know, and the difference like in which one you use polar solvent, which one is unimolecular, how many steps are involved, and which order is it, first order or second order kinetics. So these are basic things that you must know. Next up is electrolytes. So electrolytes are basically intracellular and extracellular. So you need to know which are the major extracellular, which are the major intracellular, which are cations, which are anions like sodium, potassium, calcium, magnesium are all cations, but chloride, bicarbonates are all anions. Next up we have is three theories: Sachet-Mohr's theory, Bayer's strain theory, and Coulson-Moffat's modification. So you need to know that cyclopropane mein how much is the angle strain, what is the torsional strain, the concept of dihedral angle. So these are the questions that are directly asked. That Coulson-Moffat's theory is also known as dash. So you should know that it is known as banana bond theory. So that is important. Next up is heterocycles. Heterocycles, mostly they ask the order of aromaticity or reactivity, and polynuclear hydrocarbons like phenanthrene, naphthalene, anthracene. So you need to know the different reactions: electrophilic substitution, nucleophilic substitution, elimination, addition. These are the things that you must know. And the last thing is aromaticity and basicity and acidity. So electron donating groups increases the basicity and reduce the acidity, while electron withdrawing group increases the acidity and reduce the basicity. This is a major concepts, but there are certain exceptions to those. You need to know the exceptions like ortho-para-directing groups, meta-directing groups, which one are activating, which one are deactivating. Like halogens, they are electron withdrawing group, but they are ortho-para-directing and they deactivate the ring. So that is major thing that you must know. How will you prioritize and then differentiate into different phases? So firstly, you need to know the classification, all the chemical classification, like if it's anti-helminthic, so which is vinyl pyrimidine, which has piperazine ring, like diethyl carbamazine, pyrantel pamoate, isoquinoline ring like praziquantel. So chemical classification is basically the major parent ring. You need to know the major parent ring involved in those chemical structures. Speaking about the next part is structures. So structures quite like pantoprazole, omeprazole, their structure is similar. They have benzimidazole skeleton, but there are some difference in the position of the methoxy group or methyl group. So you need to know the difference between those positions. You need to know accurately that at which position, like suppose in fluoroquinolones at 7th position, we have piperazine ring. At 6th position, we have fluorine ring, a fluorine group. So you need to know that. Phase 3 is revise. If you revise from modules, digesters, short notes, flash notes, that will be the best thing. And it will help you to understand, because chemistry is a subject that you need to practice. You cannot, मतलब आप रट्टा मार ही नहीं सकते हो. You cannot mug up. You need to practice it. So that's all for today's video. I hope you all did enjoy. If you have any queries or doubts, feel free to drop them in the comment section. Thank you so much.